Find the area of the circle with the circumference of 32 pi.
Okay, so since circumference is given, that's the first thing that I have to do. So we know our circumference is 2 pi r. And that is our circumference, so plug it in for that. I don't know why there's not enough room over here. And then what can I eliminate on the left and the right that's identical? Pi. And then we know we have to divide it by 2, so the radius must be how many? 16. And then we're looking for the area. The formula for the area is pi r squared. And when I plug it in, we get pi 16 squared. And I'm hoping you guys already have 16 squared memorized. 202. It ends with a 6. You have 9 options right here.
46.
Almost. 256. Let's say you don't know the 256. Can you do the tedious math on the side?
Yes.
Always. Boom. All right, Jake, let's read number 12.
Find the area of a trapezoid whose height is 4.5 centimeters and base of length 12 centimeters and 8 centimeters.
So for the trapezoid, if you have to look at the formula chart, go for it. I like to write it all over too. So it's our height times base 1 plus base 2, all divided by 2. Are all those information given to us?
Yes.
Which is very, very nice. So we have, that decimal, 4.5. Let's hope for the best. 12 plus 8, all divided by 2. So then let's do it in steps. What is 12 plus 8?
20.
Okay, 20. 20 divided by 2?
10.
So if I take 10 times 4.5, that's going to be what? Move your decimal once, 45. So that wasn't that bad. I was like, oh no. All right, Finley, number 13.
Find the area of a rectangle with length 11 inches and a perimeter of 38 inches.
Okay, let's start by drawing the rectangle. And they gave us one length is 11. So if this side is 11, we know the opposite is also 11. Since the perimeter is 38, I could take 38 minus 11, which gives me how many? 16. So I'm dividing 16 between these two, meaning each side must be 8. So that means our area is actually what? 88 inches squared. That was not bad. I'm surprised I can fit everything in here. I don't know what happened to me. Good things? All right, for number 14. Allie, let's read.
Find the area of a regular hexagon whose apothem is 9 centimeters.
So then, since we're looking at the apothem, I can use AP over 2, but I'm going to choose not to and do something else. Let's draw our hexagon. Ooh, I see why I needed all this room. I'm going to use all this room for number 14. Let's draw our hexagon, and then I'm going to zoom into a certain spot. So here's my hexagon. Not very pretty, but that's okay. I'm going to go ahead and cut this. Here's my apothem of 9. And normally I will find this side over here, but keep in mind, in a regular hexagon, if I have the radius, isn't that the same as one side of the equilateral triangle? Yep. So I'm going to go ahead and find this side over here. So let's go ahead and zoom into this triangle. I'm going to make it really big. I guess not really big. Here's my radius. Here's my 9. And because we have a hexagon, if I take 360 divided by 6 central angles, it is 60. But then I'm also cutting that in half, right? So that's going to make it 30 right up here. So let's do our ratio. We have x over 9 is equal to, x is opposite of 90. What was the ratio for that one? 2, very good. 9 is opposite of 60. It is radical what? 3. So I'm going to have, when I cross multiply, x root 3 is equal to 18. And I am going to divide. So we get x is equal to 18 over root 3. Since we have to do side square root 3 over 4, are we okay leaving the radical on the bottom?
Yes.
Yeah? So let's try it without it. So we have area is equal to. So what I have is that one side. I'm going to use the equilateral triangle once and multiply by 6. So here I have 6 times. And then we have side square root 3 over 4. My side is going to have another parentheses. Squared root 3 over 4. And if this looks messy, it is okay. We're going to take it step by step. Let's worry about this guy first. So when I do, I'm going to leave the 6 alone. I'm going to also leave the parentheses alone. And let's see if there's a shortcut. When I square the radical 3, what do I get?
3.
3? But I have to square the 18, right? So someone do 18 times 18 on the side somewhere. And I'm going to check it on the calculator to confirm. Should have that memorized. Oop.
144.
Ooh, not 144. That would be 12 times 12. 324. So it's going to be 324 over 3. And then we have radical 3. I'm going to put that in parentheses. A lot of parentheses today. I think this might be the hardest question of the 5 that we're doing. Now let's go ahead and reduce this right here. Can 3 go into 324 clean?
Yes.
Yes, we can, right? It's going to go in 108.
8.
So we have 6 times 108. Radical 3 over 4. Let's do 108 divided by 4.
27.
27? Can we do 27 times by 6? I'm going to confirm that. I think you're right, though.
162.
162?
Yeah.
Very good. So we have, our final answer is 162, radical 3. And our units was centimeters squared. And yes, that was a lot of work, but it could be also tedious because we had to do a lot of small math on the side. And that was for number 14. Let's write it on here. I guess my spacing was okay then. Yeah. All right. So if you're still writing, I'm going to leave it up here for like 10 more seconds and move on to 15. Oh, I have water. Oh, it's hot. They said it came by. I don't think so. Okay, Michael, let's read number 15.
Find the circumference of a circle with an area of 81 pi meters squared.
So since we're given the area, we start with that one. So we have area is equal to 81 pi. And we know our formula for the area is pi r squared. And when I plug it in, I'm plugging in 81 pi into the a. Is pi r squared. Can I eliminate something on the left and the right? The pi. And then when I square root it, what is my radius? 9. And then let's do our circumference is 2 pi r, which is 2 pi, 9. It is 18 pi meters.